Today I will share my topic is about optimize Ceph message performance. The content is as follows. First, I will show the RDMA DPDK vs TCP. Then I will show the do some test on wide compression. Use Snappy and L4. Then I will show the LCE optimization. We implement msgr-worker balancer to do some balance between msgr-worker, and we implement TCP zero copy. Then we will talk about some issues when enable Crimson with Seastar DPDK. Last we will talk about classical OSD messenger and Crimson messenger. First, we do some test with RDMA. We use Locky and test it with TCP. And we only use the cluster network use RDMA, as the public network is still TCP. And to use RDMA, we need to configure the network to lossless. Use PFC plus ECA. The result is as this picture. And the 4K run rate, it will have 5% improve. Run rate it will have 4% improve. And run rate it will have 6% improve. But when test 1 megabyte rate, sequence rate, it will decrease by 10%. Then we enable DPDK and test it with TCP. Because each DPDK thread will occupy a four core, so we only use 2 message workers to avoid using too many CPU cores. The 4K run IO run rate, it will decrease by 4%. The run rate will decrease 30%. When test 1 megabyte IO test cannot finish the property because it will have too many slow OPS, and we use the TCP dump, find it has many retransmission. So the conclusion is RDMA has no FVS advantages compared with TCP. DPDK failed to test failed to work at 1 megabyte IO test and have no benefits in 4K IO tests. Then we tested the new feature on wild compression. Data transfer between OSDs, OSD peers will support on wild comparison with Snappy, L4, CST, and the level. The result is as follows. We use 4 message workers because the compression will use many CPU, so we need to increase 1 message worker. We use FIO with different compression ratio from 20 to 100%. and found that with user snappy, it will have the best performance. When the compress ratio is 100%, it will increase the 313 milliseconds. The smaller the compression ratio, the longer the latency. So if the user compression ratio of the transfer data is high, we'll recommend use the snappy to compress it. When test Ceph messenger, we found let's introduce the LSE. ARMv 8.1 has the new large system extensions. It load and modify a shell atomic variable in L3 cache, while the load and store instruction will load and modify the atomic in L1 cache. So the LSE instruction will decrease the cost of cache coherence and get a better performance in high concurrency things. This test compare the LSE enable and disable. It shows that when the concurrency thread, it changes the concurrent threads from 1 to 2048. When the threads above 256, it will show advantage that the enable LSE will have better performance. But we use the Ceph messenger and test it. We found that disable LSE, it will have 29% improved. So because the concurrency thread is lower than 258, so the performance is more better to disable LSE. So we recommend to explicitly disable LSE in Ceph. We implement a new feature, message work balancer. We found that workload imbalance of message workers occurred in the sequential write test. Message worker will migrate a optimal connection in order to rebalance the workload. For example, message work 1 has the most workload. Message work 3 has the least workload. We will try rebalance it and move one optimal connection from message worker 1 to message worker 3. It will be more balanced than before. If after migration, if the workload is still imbalanced than the predefined threshold, we will reduce balance from move one optimal connection from the more to the least to rebalance the whole workload. With this feature, The performance of sequential write improved by 9% with message worker balancer. We implement another feature is TCP zero copy. In kernel 4.14, it implements send message zero copy to reduce the overhead of memory copy. We implement dynamic send message zero copy in Ceph PostGIS stack, which only be used when the data size is larger than threshold. This flow. First, when a connection is created, we will set a socket operator with zero copy and create a file event to register for error event. When it call socket send, we will check the buffer length. If the buffer length is lower than the threshold, we will use the original send message. If the message length is larger than threshold, we will send a message with zero copy. When the message is finished, kernel will signal message worker. Message worker then start to receive message, call receive message to get the send out range. It will give me a low to high sequence. With the sequence, we will clear the buffer. At here we will we send a message saying we will append the buffer and append the buffer to the buffer list. When we get the RQ message, we know the low to high sequence ID. Then we will clear the buffer list. Clear. So we'll erase some buffer list from the low to high. Before close, we will clear the buffer list. If we close if when closed there are still some buffer list not clear, we will clear it again. Use this feature, we will test that 16 KB random rate will increase by 5%. This link talking about Yinxin do some experience. Yinxin do some experiment with Crimson OSD message. Use the Seastar DPDK. He found following issues. First, Crimson message with Seastar DPDK cannot establish a loopback connection and native stack. We added some in the port TX, in the transmit function, we will check if the destination MAC is the same address as source MAC. If it's the same, we will call L2 receive to forward it to up layer to fix this issue. The second is cannot start a multi-OSD instance because all the OSD in one host use the same NIC. DPDK use the same NIC. DPDK must work at primary and slave, but Seastar do not support work at a slave. So we use NIC SR-IOV to generate many VF NICs. Then we we assign its OSD exclusive VF NIC. Then each OSD has its own NIC. It will start okay. Another issue is move socket across core is not supported, and we need to implement packets forward machine. We need to introduce the forward packets across core, which may the performance may not very good, but it can support move socket across cores. Seastar now Seastar is only support one OSD network, and OSD should support a multi-network. They use one for public network and another for cluster network. So we need to modify Seastar to support a multi-network. The last issue is PEF collision emergency tester is failed to work with too many jobs or large LDEPs. As I mentioned before, we also have this issue. We use the TCP dump command to capture and analyze packets. It's found that a large number of fast retransmission are performed. So there's still a lot of work needed to do with Seastar community to improve DPDK protocol stack. We think is classical OSD messages. That Ceph need a faster NIC. We use the FIO messaging plugin and test it. We found that with 25G NIC, it can provide about 616K LPS. Therefore, the classical OSD, one host can only cannot afford so much LPS. So we think 25G NIC is enough. Faster NIC cannot furthermore improve LPS. And that's Ceph need to offload a network stack. We use RDMA stack. Can offload some network stack, but we use top to PEF. You use PEF to attach the one OSD, and found that most it's about 59% of CPU. 59% of CPU are OP work process. The network transmitter and the message send and receive handle. The 4K run-write message transmission occupy only 23% of the CPU. We assign its OSD have 4 CPU, so the network occupy only about one CPU. Therefore, offloaded CPU cannot bring much benefit. RDMA stack implement I think RDMA stack needed to implement RDMA read feature. Use RDMA reader to process large packets. It's more efficient than send, RDMA send. RDMA reader first, the client will send first one node will send an RDMA request to the server. The server side will proactively read the large packets to avoid congestion. As I mentioned before, the 1 megabyte test is sequential rate is lower than in TCP. It's because of the congestion. About Crimson message, I think we can deploy Crimson with Seastar DPDK and fix some issue to fix the issues mentioned before. And we need to work with the community to improve the Seastar DPDK. Any questions?